All right, so like I said, there's 5 properties we're going to cover today. 2 of them we've already covered. The sum and difference, when you can break them apart, you can break up apart if you have the same bounds or no bounds, and you're adding 2 functions, you can break them apart and each give them their own. Okay, we've done that one. And then the constant multiple, where if you just have a number, a coefficient, you can put it in front. You don't have to, but you can. Okay, that one we have. The 3 big ones that we're going to talk about that you're going to see, one is the reversal. One is called the reversal. Okay, so when we have bounds, this is only when we have bounds, right? The lower bound, or let me put this on here actually. Let me write it on the notes. So for us to do any type of integration, for us to solve, the bounds have to be, has to go from lower bound to upper bound. Okay? Lower meaning smaller number. Upper meaning bigger number, right? Probably let me put that. Smaller number, bigger number. Okay? For us to actually do the problem, so we have to have the low number on the bottom and the big number on top. Okay? Sometimes you won't have that. Sometimes you won't have that. Sometimes they'll switch it around. Sometimes they'll do something like this, where they'll do 5 to 0, like that. Well, 5 is not the smaller number. 0 is. The bounds need to be reversed. And you can do that. Before we do anything, we have to do that. How do you do that? You do what's called the reverse interval. You put a -1 in front. You can flip the bounds as long as you put a -1 or a negative in front. Then you can flip them. Okay? Because if I have a number like 5 here and a number like 0 here, I can't do this problem because they're not in the correct order. The lower number needs to be on the bottom and the bigger number needs to be on top. I can do that. That's within my abilities. But in order to do that, I have to put a -1 in front and then go on and do the problem like you would. Okay, so some of these you're going to see and you're going to be like, well, the bounds are out of order. This one needs to be here, this one needs to be here. You can change them, just put a -1 in front. The next one, the next new one, 0 length. This one's kind of common sense, right? What is integration? Integration is finding what? Area under the curve, right? And what if we're finding area from A to A? What does that mean? We're finding area from A to A. Yeah, it's missing something, right? So let's say I have an area A. And I want you to find, and then let's say it goes from A to B like that. Okay? And then they want you to find area from A to A.
It's just a straight line.
It's just the segment, right? It's just from there to there. And segments, lines, they have no width. They have 0 width. So it's got a length, but it's got no width. So if it has no width, I can't find the area, right? So that's why the area is 0. Or better, I should explain it. If it has no width, it's always going to be times 0, right? So length times width is always 0, so that's why it's 0. Okay, that one's kind of a common sense thing, right? If it's from A to A, if it's from the same number to the same number, the area is just going to be 0. Okay, and then the last one is kind of, so you can kind of see from A to B, same function, right? These are all the same function, f of x. So from A to C, you can break up into 2 smaller pieces, A to B, and then it picks up from B to C, right? So that one's kind of like right? So you can say area from A to C, or you can say, give me the area from A to B, and then add it to the area from B to C. It's the same thing, right? It's just two pieces instead of one whole. Okay? So a lot of those, especially the zero and the adding intervals, they're just common sense, right? They're just common sense. So the properties aren't that bad. The properties aren't that bad. Okay? So let's look at some problems. So given the area from 2 to 6 for f of x is 10. So they've given us the area. They said the area is already 10. Okay? And then the area for g of x for the same interval is -2. Right? Okay, so find the following. Area from 2 to 6, same bounds, right? Same bounds, adding the 2. So what we would do is break those up into two smaller problems. This is using the sum rule. So we would go, from 2 to 6 for f of x. Remember, dx is important because that's the width. Without dx, there is no width, and we can't find area without a width. Since it's plus, you would go plus for g of x. Well, the area from 2 to 6 for f of x, it says is 10. The area from 2 to 6 for g of x, it says is -2. So we would add those together, and you would get 8. The area for both of them added together is 8. Okay? B is the same, but just subtraction. Subtraction. So we would split it up from 2 to 6 for g of x dx minus from 2 to 6 f of x dx. This guy is -2 minus. This guy is +10. You get -12. The area is -12. Okay, so that's using the first sum and difference. We've used that one. Like I said, we've used that one before. That one's not a new one. Okay. C and D. C is actually the same as B, right? Are my eyes deceiving me, or are they exactly the same?
D is the same as B.
D is the same as B, right?
Yeah.
Yeah, that must just be a duplicate. Okay, so C. We won't do D then. What do we do with the 3?
You move it to the front?
Move it to the front. We've done this before. Move it to the front. So you get 3 area from 2 to 6 of f of x. Well, the area from 2 to 6 for f of x is 10. So you get 30. Area is 30. And this one's the same as this one. The same problem. So we won't do it again. So instead of that one, let me give you a different one. Let me give you a different one. So we'll do a different D. We'll do a different D. Let's say this. I think this is what the problem was supposed to be, but they just... Will we get the same answer as I got in B? No. Why not?
Because it's flipped around, so it'll be a positive minus a negative, which would be stay positive.
For subtraction, order matters. For subtraction, when you're subtracting two numbers, whichever one comes first matters. When you're adding or multiplying, order doesn't matter. You can add two numbers, but for subtraction, order matters. So this guy is going to be 10 minus, this guy is going to be -2, so it actually becomes +12 instead of -12. So for subtraction and division, order matters. For addition and multiplication, order doesn't matter. Order is exactly the same. Okay. All right. All right, so let's do some of these over here now. Number 2. So for f of x, the area under the curve for f of x from 0 to 5 is 10. Same function f of x, but now it's from 5 to 7. That one's 3. Okay. What is the area under the curve from 0 to 7? Sometimes these are easier if you draw a picture. Sometimes you don't need to, but I sometimes, especially when I'm doing it the first time, I sometimes draw a picture. So I don't know what f of x looks like, but I'm just going to kind of guess. It's positive, so it's above the x-axis. So we got 0 to 5, and then 7, right? So from 0 to 5, I'm just going to draw a generic function. So from 0 to 5, the area is 10. And then from 5 to 7, the area is 3. Okay. So now they want to know what the area is from 0 to 7. Add them together. Pretty easy to see when you have a picture in front of you. So sometimes it's beneficial to draw a picture. Sometimes it's not. It's up to you. Okay, so B. Don't I have that? Isn't that 10? Negative 10, good, because the bounds are flipped, right? This guy needs to go up here, and this guy needs to go down there. So before I can do anything, I got to flip the bounds. So 5 needs to go on top, 0 needs to go on bottom. I can do that so long as I put a negative 1 in front. So long as you multiply your answer by negative 1. The area from 0 to 5 is 10. So you get negative 10. Even though it's above the x-axis, it's negative 10 because the bounds were switched. The bounds needed to be switched. Okay. All right, so I want you to do C and D. Do C and D. Based on the same thing, based on the same picture, the same example number 2. You got to go piece by piece or else it's just going to become more confusing. Okay? So the back page is more of the same, but what I want to focus on is I want to do another problem like that guy there. So I'm going to give you a problem like number 5. So if we don't finish the last page, I'm not worried about it because it's more of the same. But what I do want to do is give you another problem like number 5. Okay, so what's the first thing?
To apply the rule to minus -2.
What rule do we have to apply? Or what do we have to do? You don't have to tell me the name of the rule, but just what do we have to do?
To reverse them and add a -1 and 2.
Yeah, so for this guy here, the bounds are reversed. So I got to rewrite it so that it's correct. So it should be written as -2 down here, right? +9 there. What does that do when I flip the bounds? What does it do when I flip the bounds? To flip the bounds, I can do that, but what do I also have to do? Put in -1, right? But they've already solved it for me and said it's -6.
So you make the 6 positive.
So the 6, that means is positive. Okay. 6 is actually supposed to be positive. Okay. 10 to 9, good. That one's good. What is the value from -2 to 10?
11.
Yeah, I don't know yet, so let's figure it out. So again, for me, with these, I always draw a little sketch. That's just me because I'm more of a visual person as opposed to someone who can see everything in my head. Okay, so I'm going to go -2 to 9, positive 6. So again, is this exactly what's happening? I don't know, but it's just going to give me a little sketch so that I know what I'm looking at. Okay, so that's this guy. That's that area. And then they tell me from 9 to 10, the area is 5. That's also positive. So last thing is solve it. What's the area for this function from -2 to 10? How do I do that?
You add them.
You just add them, yeah. 6 plus 5 is 11. Now, do you need to draw a picture? No. Is it required? No. It helps me, though. It does help me to do these. Okay? It does help me to do those. Okay? All right. Okay, so the last thing I want you to do is do that last page. Do that last page, and then we're done. And then tomorrow I'll give you the practice. So 6a, it's just from 2 to 2, so it's 0. 6b, the bounds are flipped, so you got to put a -1, so your answer is just going to be, so if you get a positive answer, change it to negative. If you get a negative answer, change it to positive. So -1 times 8, -8. C, you're moving the 3 in front. So it would be 3 times -4, -12. D, 2 to 5 is not up there. I have 1 to 2, 1 to 5, 1 to 5. So it's not up there, so you got to get a little creative here. From 2 to 5, I don't have that. So they want from 2 to 5. I don't have from 2 to 5 for F, but I have from 1 to 2. And then I have from 1 to 5. So from 1 to 5, it's 6. From 1 to 2, the area is -4. So I'm going to draw a little sketch here. Okay. So from 1 to 2, we got -4. And from 2 to 5, I don't know. But from 1 to 5, it's 6. So the whole thing is +6. So what do I do? Subtract the whole minus the piece. The whole is 6 minus the piece, which is -4. You get +10. Okay. E, you just break them up, add them together. F, you subtract, but you got to move the 4 in front first. So I won't finish E and F, but I'll show you at least how I did do it. So you find the area for both, add them together. For number 4, you subtract them, but you just multiply the first one by 4. So this area, let's see, from 1 to 5 is 6 and 8. So 6 plus 8, so 14. This one is 6 minus 8. So you get 24 minus 8, which is 16. And that's it.